Hey scientific genius people, how are you today? So today I'm going to solve this practice paper which I had given you few days back, and the first question is about the states of matter. So the conditions are given, and we are supposed to find out which state of matter is over here. So if you look carefully, the molecules are at a great distance, and substance occupies all the space available. So this is gas. Molecules are only able to vibrate about their fixed positions. Of course, this is solid, and it does not even require container to maintain its shape. So this is solid. And the movement of molecules amongst each other and does not necessarily fill its container. That means if you take 500 ml water and if you put it in 4 liters of container, then it is not going to fill up the entire space. So this is liquid, right? Okay. And what is the state of matter just before a substance boils? So boiling is from liquid to gas. So when boiling takes place, the substance is in liquid state. After boiling finishes, it is in gas state. So just before substance boils, it is in liquid state. Describe what happens. Okay, I'm coming back to this question at the end. State two differences between boiling and evaporation. I don't think that we need to discuss this. We have already done many times in the classroom. So I would basically skip this question. What is the state of matter just before substance melts? So after melting it becomes liquid. Before melting it is in solid form. Aluminum melts at 660 degree. So at what temperature does it freeze? And I would like to tell my viewers that water changes back into ice at 0 degree, and ice again melts back into water at 0 degree. So freezing point and melting point are one and the same. So the answer is 660 degree Celsius, which is given over here. Now describe what happens to the molecules during boiling. So if you are given, suppose we take a liquid in a container. So this is liquid, and there are liquid molecules everywhere. So these are liquid molecules present in and on the surface. Now these water molecules, when they are being heated, the temperature rises to 100 degree. Now these all water molecules are actually bonded, so they break the bonds, their amplitudes of vibration increase, and finally after breaking the bond they convert themselves into gaseous state and they start leaving. So this is what is to be written in short in our own words. In next problem, we are being given that a ray of light passes into water from air. So this is air and this is water. So it goes from rarer to denser. So of course it will bend towards normal. And we are supposed to mark the angle of incidence I. So angle of incidence is between normal. So this is normal, which is at an angle of 90 degree to the surface, and the incident ray. So this angle is I. Moving on to B part, you are supposed to redraw this diagram again, right, which is given over here. I'm just marking it over here. So in the figure below, the ray of light is shown, and this 40 degree is given to us. That means now this time it is going from denser to rarer. So instead of going straight, it will bend away from the normal, right? So this angle of refraction, this is the angle of incidence. Now this is the angle of refraction. It will be of course more than 40 degrees Celsius, right? This is the picture. Now they are telling that redraw the diagram and draw accurately the path of ray. So approximately away from the normal and more angle compared to 40 degree, just draw it. Now they are telling that if we increase the angle from 40 to 70 degree, so that means now the angle of incidence is, we are increasing. So this angle becomes more. So if the angle of incidence increases, the angle of refraction must also increase. So the ray would go like this, and the angle of refraction also increases. So on increasing I, the increase in R also takes place, but R has to be always greater than I, because this is from denser to rarer, right? So it would bend still more. Moving on to the next problem. This is a very nice problem related to Pascal's law. And here they are telling us that we have a piston whose area is 0.01 meter square, and everything is given, G is given, and we are supposed to apply 100 Newton force over here. So I'm going to apply 100 Newton force over here. So if you push this piston, this liquid is going to apply pressure in all these pistons. So these pistons would basically move up, all 4 pistons, and finally the car would move up. Now, I know what is the force applied, I know what is the area over here. So pressure is equal to force upon area. So this is equal to 100 Newton upon 0.01 meter square. So 100 upon 0.01 is actually 10,000 pascals. Newton per meter square is Pascal. Now the pressure generated in the liquid is 10,000 pascals, and we do know that Pascal's law states that the pressure transmits equally in all directions. So this pressure is equally transmitted. So 10,000 pascals reaching over here, and it hits this piston. Now this piston has area 0.02, double the area of this one. So that means from here, if I calculate the force is equal to pressure into area. So this piston has area 0.02 meter square. All 4 pistons are equal in area, and the pressure reaching as per Pascal's law is same. So fluid transmits equal pressure without getting diminished in all directions. So the pressure reaching over here is again 10,000 pascals. Pressure reaching over here is again 10,000 pascals, right? So any one of the piston area is 0.02 meter square, multiply by 10,000 Newton per meter square, that is pascals. Meter square getting cancelled. So this is 10,000 into 0.02. So my answer is going to be 1 decimal, 2 decimal, and so my answer would be 200 newtons. Actually, I have made a very small mistake. Instead of 100 Newton, it is 1000 Newton. So if I write 1000 Newton over here, then it would be 1 lakh Pascal. So 1 lakh Pascal reaching everywhere, right? And this would be 1 lakh Pascal. So my answer would be 2000 Newton. So that means this piston moves upwards with a force of 2000 Newton. This also moves up with 2000 Newton. So that means total upward force is 2000, 2000, 2000, 2000. So it is 8000 Newton. Now, these 2 planks, they have weight in the downward direction. All weights are in downward direction. This car has weight in the downward direction. Let us assume that the weight of the car is W. Now this wooden plank has got weight 1000 Newton. So 1000 Newton this, 1000 Newton this. So total downward force is 1000 because each plank weighs 1000. So it is 2000 Newton plus weight of the car also. Now since this is in equilibrium, nor this car is moving up nor this car is moving down, right? The system is in equilibrium. So total upward and total downward force must remain same. So 2000 plus W is equal to 8000. W is equal to 6000 Newton, which is the weight of the car. Now weight is equal to mg. So W is equal to m into g, and weight of the car is 6000. Mass we don't know, g is 10. So getting cancelled. So mass of the car is 600 kilogram. Right. Pressure caused by piston A on the fluid. Piston A on the fluid is 1 lakh Pascal. Right. And the weight mass of the car is this one. Total upward force caused by the fluid is 8000 Newton. right? Total upward force caused by the fluid is 8000 Newton. So hopefully you have understood this question well. Moving on to the next question, question number 4. This is a light from laser, and laser is monochromatic, which means only single color, like red or green, or we can assume this as a red color, right? So red laser light coming from here, and it is falling on the prism. Then we know that from here, instead of going straight, it will bend towards the normal, and from here again, instead of going straight, it will bend away from the normal. So the red laser dot is seen over here on the screen. Correct. So this is what happens. So what will be seen on the screen? So you will see a dot. Laser dot will be seen over here. Redraw the complete diagram. You can do that. The beam of light of laser is replaced by a beam of white light. State now what is seen. Now if we use white light will be splitted up by this prism into 7 colors, and all 7 colors would reach over here. So we would get a spectrum. We would get band of all 7 colors forming over here on the screen. This is question number 5, numbering mistake from my side, and the ray of red light passes through a rectangular glass block like this, and it is shown over here, right? This angle is 45 degree, this is 26 degree, and angle of emergence and angle of incidence are always equal in the glass slab. We have already studied. So angle of incidence is 45 degree. So the angle of emergence is again 45 degree, right? And we do know that when you extend this incident ray forward, it must be parallel to this emergent ray, and the distance between them is called lateral shift. Now, what name describes what happens to the ray of light at B? So at B, the ray bends, so it is refraction. We are supposed to find out the correct value of angle theta, so or angle of emergence, which is 45 degree, right? As discussed that in case of glass slab, angle of incidence and emergence are same. Again, similar type of question. A ray of blue light is directed into glass prism. So since it is a blue light, again, moving on to the next problem, we have a box over here and the rays are coming in like this, and then the rays are going out. So which one of the following is our correct answer? Answer is glass slab, because in case of glass slab only lateral shift happens. So the ray was supposed to go straight, but instead it is shifting by this much amount. So this is a glass slab, right? So we can see, we have just seen the question. So instead of going straight, it is shifting parallelly. So here also the ray of light is, instead of going straight, it is shifting parallelly. So this is a glass slab. Next question, we are being given a man who sees a small child. He's actually drowning, and this is ice. Now, question says that why it would be unsafe for the man to walk on the ice. It is because the weight of the man is in the downward direction, and the weight is concentrated on very small area because his feet are small. So the pressure is equal to weight upon area, where area is small, pressure would be too large, then this pressure would be okay or good enough in order to break the ice. Then this man, if he tries to walk on it, then he would also break the ice, and he would also drown inside. So it's better that he cannot change its weight. This is constant. But yes, if this man sleeps and if he starts crawling towards the man, then what happens? The entire weight is now falling on a larger area because the body is quite larger compared to the feet. So under that situation he can reduce the pressure, because weight doesn't break the ice, pressure does. So this is what is the solution to this problem, second number. Now question number 8 says that a water tank has rectangular base, this multiplied by this, and contains this much water. So we are supposed to calculate the weight of the water. So weight is equal to mg, right? So weight of the water, question number 8. So weight of the water is equal to mg, and mass of the water is given to us. So it is 1440 kg into g. If it is not given, I am going to take this as 10 meter per second square. So 14400 Newton is the answer. So the weight is being found now. Now they are asking the pressure exerted by the water at the base of the tank. We know that pressure exerted is equal to H rho g, or you can also use force upon area. So this is a part, and now this is the second part, I guess. Yes. So this was first part. Now second part is the pressure. Pressure is equal. You can also apply H rho g, but you will have to find out H. That would be quite difficult for you. You can do that also. So this is equal to weight upon area. So area of the base. Now the tank, rectangular tank, has base area, so which is given to us. So suppose if I draw this rectangular base, right, has got length 1.5 meter and then the breadth 1.2 meter. So the area of the base, because if the liquid is filled till here, then the base area of the liquid will also be the same. So area is 1.5 meter into 1.2. So the weight is given as 14400 Newton upon 1.5 into 1.2 meter square. Newton per meter square is pascals. I think if you calculate, you will get your answer, right? So this I am leaving on the fine sense of problem solving numerical ability of my viewers, right? And moving on to the next part. Figure B shows two water tank. Yes, the depth of both the water tank is same, right? The liquid is filled till same depth, H is same, that is 1.4 meter. Density is given. Pressure exerted by two tanks are equal, right? And calculate this pressure. So again, pressure is equal to H rho g. You can apply this over here. So now I am going to solve B part. Now in B part, first part is pressure is equal to H rho g, right? H is the depth, which is 1.4 meter. Density of water is 1000 kg per meter cube. G, if it is not given, we can take this as 10 meter per second square. So this is 14 into 1000, so 14000, and this is Pascal. So the answer is 14,000 Pascal. Equal small volumes of water are removed from each tank, right? State which tank P, Q or P or Q now has greater water pressure at its base. Explain your answer. So the answer over here would be more pressure would be generated at this Q, because if you look carefully, I am supposed to take out equal volume. So volume is equal to area multiplied by height. So if I choose to pull out 1 liter water from both, so here area A is constant, but here the area is very large. So if I want to pull out the volume, volume is the product of area into height or area into length also. This area is small, this area is large, right? So since if I pull out 1 liter water from here, more the area, so less will be the height. So you can consider this part to be 1 liter. But over here, since area is less, the height must increase. So over here, this is 1 liter. So clearly it is visible. If I remove this, then the overall H would decrease. And here the overall H is comparatively larger than over here. And pressure is equal to H rho G. So H is more over here. So the pressure at Q would be larger. Right? So finish off this assignment, and if you have any doubts, do comment in the comment section. Thank you for watching the video.